All right, so we're doing multiplication and division. Numbers and scientific notation. Okay, so this one, I'm going to start off with multiplication. And what I'm going to do here is I'm going to do an example first, and then I'll explain what the rule is, because I think it makes more sense that way, this thing. So, call this example 1. All right, so let's do 4 times 10 to the 4th times 2 times 10 to the 3rd. And what I want to do here is try to explain to you why the rule exists. So what I'm going to do is I'm going to rewrite this the long way. So 4 times 10 to the 4th is actually 4 times 10 times 10 times 10 times 10. I think that's what 4 times 10 to the 4th power means. And then it's multiplied by 2 times 10 times 10 times 10. Right, that's 10 to the 3rd. And you know that when you multiply things, the order doesn't matter, right? Like if I said 3 times 4 times 5, or if I said 3 times 5 times 4, or 5 times 4 times 3, the order is irrelevant, right? Either way, you're going to get the same answer no matter what order you multiply them. And so the same is true here. And so really, if I want to, I could multiply these two numbers first, and then I can multiply all the 10s together. So let's rewrite it this way. 4 times 2 times, and then what I'm going to do is I'm going to take these 3 10s and these 4 10s and multiply all of them at the same time. 10 times 10 times 10 times 10 times 10 times 10 times 10. And so now it becomes very obvious. It's just 4 times 2 times what? Yeah, 10 to the 7th. We just count up the 10s. There's 7 of them. So it's times 10 to the 7th. 8 times 10 to the 7th. So the reason I do this is because I want you to understand why it is that when we multiply numbers with exponents, why we're adding the exponents. Why are we adding 3 and 4? Because that's the number of 10s. 3 plus 4 equals 7 10s multiplied together. So that's where this rule comes from. So the rule is add exponents and multiply coefficients. Coefficients are, of course, the 4 and the 2, right? We just multiply them. And this is one of those things where if you're ever taking a test or something, you forget what the rule is. You can always write out a small problem and figure out what the rule is by remembering how to do this. All right, let's do one, and we're just going to use the rule. We're not going to go through all them steps and stuff. Let's do a different problem. Let's try 3 times 10 to the 8th times, should be 8, times 3 times 10 to the 5th. Okay, so in reality, we're not going to write out these 10s every time. All we're really going to do is 3 times 3 times 10 to the power of, that's 8 plus 5. And so our answer is just going to be 9 times 10 to the power of 13. That's it. Questions? All right, occasionally, well, most of the time actually with multiplication, you may get a 2-digit number, so when you're done you'll have to convert your answer to proper scientific notation. Let's do one like that. Let's do 7 times 10 to the 15th power times 4 times 10 to the 6th power. Okay, so it's going to be 7 times 4 times 10 to the 15 plus 6. So that's 28 times 10 to the 21st power. So we got our answer. The only thing here is we can't, this isn't proper scientific notation. We should only have the decimal to the right of the first non-zero number. We shouldn't have a 2-digit number. So what we have to do is we have to take the decimal that we know is supposed to be here. It is here, right? And put it there where it's supposed to go. It's going to be 2.8. And since I made this smaller, this gets bigger. Times 10 to the 22nd. So at the end of any problem, we always want to put our answer in the proper scientific notation. Questions so far? Yep.
If it was a 2-digit, then you only move it over once.
Yep. And if it was a 3-digit number, if I had 312 times 10 to the 5th, then I got to move it twice. And this is 3.12 times 10 to the 7th. However many times you got to move it to get that decimal to the right of the first non-zero. Any questions? All right, let's do division. All right. Let's do 6 times 10 to the 5th. And here we have to use parentheses. It matters here. Divided by, this will be the only time you ever see me use this stupid divided by sign. Usually I'll just make fractions. 3 times 10 to the 2nd power. All right, so again, I'm going to do the first one. We're going to write it out so we can see what's happening. So it's going to be 6 times 10 times 10 times 10 times 10 times 10. So that's 6 times 10 to the 5th. Divided by 3 times 10 times 10 second. And so when we write it out this way, it becomes immediately obvious what we have to do, right? 10 over 10 is 1, so these 10s cancel, right? So you say 10, 10, 10, 10, they go away. And what we're left with is 6 divided by 3 times 10 to the power of whatever's left, which is 3 of them, 10 to the 3rd. That's 2 times 10 to the 3rd.
Oh, because you took out the
So this canceling is the reason you're taught to subtract the exponents, because you're taking away however many's on the bottom from the top. So the rule for division subtract exponents. It's always the first minus the second. And divide coefficients. And again, it's the first one divided by the second one. You can't change the order because one's bigger or anything like that. We got to go in the order. All right, so let's do, what's that right here? Let's go over here. Let's do 8 times 10 to the power of 70 divided by, I should use parentheses here, 2 times 10 to the power of 40. So here's our coefficients, 8 and 2. So it's going to be 8 divided by 2 times 10 to the power of, and then 70 minus 40. So 8 divided by 2 is 4 times 10 to the power of 30. Questions so far? How many people are getting this and think this is really easy? All right, good. All right, let's do one where we get an answer that's not in proper scientific notation, and that'll be the last one. So we could have something like 4 times 10 to the 11 divided by 8 times 10 to the 5. So here when we do this one, what we're going to end up with is 4 divided by 8 times 10 to the power of 11 minus 5. So we're going to get a half, right? 4 over 8 is a half. So 0.5 times 10 to the power of 6. So again, this is not proper scientific notation. Now we got a number where there's no non-zero to the left of the decimal, so we've got to move the decimal this way. We've got to make this number bigger. Since we're making that bigger, this has to get smaller. So we're going to change this to 5 times 10 to the power of 5. Questions? Maybe another example? Pretty good. Good. All right, I'll stop here. And here's the worksheet, Rocco. Yeah.